So I'm going to talk today about RoRoRoomba, and that's Roomba on Ruby on Rails. And this is a rather different presentation than what you might be used to. So I'm going to start off by saying a big thank you to iRobot, and especially Nancy and Joshua at iRobot for supplying us, shipping 2 brand new Roombas to RailsConf for us to use in some demos that we're going to do. That was really awesome of them. And we just kind of contacted them like 3 or 4 weeks ago and said, hey, we want to do a presentation about Roomba, and they were more than gracious about sending us the Roombas, so thank you very much. The next thing I'd like to do is say a big thank you to CookPad, because after my presentation was selected, my proposal was selected, I was trying to figure out how in the world am I going to get to the US and book all the hotels and take care of everything, and CookPad did an awesome job of just encouraging me and setting up everything for me. So that was really awesome that the company that I work for is giving back to the community in such a big way. So big thanks to them. So without further ado, I'd like to start with some introductions. And these Roombas are not the Roombas that I've been working with. In fact, the Roomba that I've been working with the most time is still in Japan, and this is him. This is Ru. And you see there he's got a kitchen knife, a butter knife attached to him. And I did that so that I wanted to arm him so that way he would remember fondly the person that first gave him a weapon when the robot uprising happens. I thought one knife alone wasn't actually enough, considering how great and awesome Roomba was. So I upped it up a notch, gave him some more utensils. He looks a little more fearsome this way. So that's my Roomba. Konnichiwa, my name is Charles Abbott. I work for CookPad. I've been there for a little over a year in Japan, based out of Tokyo. I run a little blog called forthecode.org, and this blog has really almost nothing to do with code, so it's kind of oxymoronic, but the blog itself is just my journey moving to Japan 3 years ago. I didn't know anything about Japanese culture. I knew almost zero language at that time. And this is my daily life about all the trials that I faced while living in Japan. So if any of you are even remotely interested in Japan, please check out the blog. I still write at least 2 or 3 times a week about new and interesting things that I find. So since the 5th or 6th grade, one of my favorite quotes was by an author named Daniel J. Boorstin. He wrote this amazing series of books, historical books. He was actually the historian at the Library of Congress. It was the discoverers, the creators, and the seekers. I don't know if any of you have read these books, but they're really, really great. And my favorite quote comes from him, and he says that the greatest obstacle to discovery is not ignorance, but the illusion of knowledge. And it essentially means that throughout human history, the greatest things that blocked any new paradigm shift were the fact that people were holding on to old ideas or holding on to what they presumed was only the right way to do something. And I think this quote still has a lot to do with me on a daily basis, and especially with this presentation as well, because 5-6 months ago when I started out on this hacking Roomba journey, I knew absolutely nothing about physical computing. I knew nothing about wiring. I had never done soldering. I'd never done anything I'm going to talk to you about today. And so ignorance was my best friend. And I hope that through this journey in this presentation, I can at least encourage any of you that have never done anything like this to step out and just try it. So when I first got my Roomba about 6-7 months ago, I purchased a Roomba, and I opened it up, and the packaging around the Roomba had this sticker, which was really awesome. It says, this robot has an API, it can be hacked, and if you open this bag, you are accepting the end user license agreement that says your Roomba can be hacked. And we encourage you to do so. iRobot is really awesome about the open interface that they have. And so this particular Roomba here, I took the sticker off and pasted it on here so I would remember the end user license agreement while I'm hacking and running my Roomba around. About 4 months ago at the Tokyo Rails meetup that we host, there was a call for any ideas for projects that anyone might have. And I decided to come before the Tokyo Rails meetup and see if anyone was interested in hacking Roombas with Ruby. And my presentation at that time was called 3 R's. And essentially it was, I have this idea and I want to use Ruby. I know that there's a serial port gem that we can use. And I want to use Ruby, and I want to use Rails, and I want to do something with both of those and control my Roomba, just to prove that it can be done. And the idea was, hey, you got serial port Ruby and will control Roomba. You can have a Rails site that's going to direct all your requests to your Roomba remotely. Something's going to happen in a profit, right? That's the quintessential equation. At the time, I really didn't have many resources. In fact, I had only come across a couple blogs that said that hacking Roombas was doable. It's something that's not incredibly difficult other than just trying to figure out the API, etc. But every package and every project that had been created for hacking Roombas, which there weren't that many, there were only a couple, were all written in Java or some other language. There was nothing available out there in Ruby. So I decided to get started, and the first place to start was to try to figure out how do I actually connect to the Roomba. And I looked at the documentation, and come to find out Roomba has a serial port. It's a 7-pin serial port, and I had to go out and find a cable that would match a 7-pin serial port. Oops. Underneath Roomba's handle, there's the serial port. This is probably really impossible for anyone to see, but I'm just going to point it out. On the newer models, there's a handle, and underneath there's the actual serial port. On some of the older models, these serial ports are hidden underneath covers that you have to pop off the top of the Roomba. So where do you get a 7-pin serial adapter? Well, one of the best replacements for a 7-pin serial adapter is actually an 8-pin serial Mac printer cable. And I spent a couple hours in Akihabara, if any of you have been to Tokyo. Akihabara is a section of Tokyo that's referred to as Electric City because there's just hundreds and hundreds of stores of used and new computer equipment. And for instance, this particular Apple used Mac store that I went to had just giant bins of old stuff, cables, and everything that you could dig through. And after a couple hours of digging, I found one good cable that I could use. And then something crazy happened. Like about 3 weeks after I got this cable and started hacking on Roomba, my firstborn child came into the world, and suddenly all that free time that I thought I was going to be hacking on Roomba somehow disappeared, and I never expected that I would really be sitting up like every 2 hours of the night. That's incredible. But anyways, back on track. Not long after, well, about a month or two later, I finally picked up that Arduino that I had bought and picked up that cable again, and I said, I've really got to do something with this Roomba. And I started looking at the Arduino layout and trying to figure out how do I use the Arduino and connect it to the Roomba. And Arduino, on the top right, there are 2 pins. There's the receive and the transmit pin. That was loud. And then in the bottom, there is some power connectors for the 9-volt and the ground. And that's all that you need to connect with Roomba, is to have a transmit receive line and the 9-volt and the ground. Now I'm going to save you guys some time if you decide to go out and hack Roomba. There's 2 sets of documentation out there. They're both published by iRobot. There's the one on the left, which is the Roomba Open Interface, or OI or ROI. And then the one on the right is the iRobot Roomba Serial Command Interface, SCI specification. The one on the right looks awesome. The formatting is great. They've got pictures in there. And these are both the front page covers. But actually, the one on the left is the newest documentation. And don't even look at the one on the right unless you just want to see some pictures. So what is the ROI, Roomba Open Interface, or API? I'm going to probably refer to the ROI, Roomba Open Interface, as just an API from now on, so that way we don't get this confused with return on investment or anything. But the API is specified in their documents that, for instance, this is a page from the API that specifies some sensors that you can get from Roomba. There's a bumps and wheels drop sensor. There's a wall sensor to tell you if there's a wall coming up. There's one that tells you if there's a cliff ahead, so that way Roomba doesn't fall off your stairs or anything like that. And it just tells you what is the ID of the packet. For instance, the bumps and wheels drop is packet ID 7, and it tells you that it's a single data byte and it's an unsigned. For instance, with the bumps and wheels drops, which is the top there, each bit in that byte represents some different sensor reading. Wall, on the other hand, is just a single data byte, and it's unsigned, and it just has a range value of 0 to 1. Some of the other ones may have range values to 255, or they might be 2 bytes that represent a 16-bit signed integer. So this is the documentation, and after referring to the documentation, I was able to wire up wire up the Arduino, excuse me. This is the cable after I'd cut it and pulled out the wires and connected it to the Arduino, connected to the power and to the receive and the transmit lines. And this is when I connected the Arduino to the Roomba. As soon as you connect any Arduino or external device into the Roomba serial port. If it's connected, if it's properly set up, the Roomba will light up and recognize that there's some device attached to it, but it won't do anything other than just light up. So what do I have? I actually, at this point, I had the idea that I was going to use Ruby, and I was going to send commands to Arduino, and then Arduino would somehow forward it to Roomba. And Roomba only communicates on the byte level, and then Arduino, I really wasn't sure what was happening with Arduino at that time, but come to find out, it's not so easy to just pass commands from Ruby straight to Roomba using Arduino. In actuality, you end up writing what are called Arduino sketches, and there might be quite a few of you out there that are very familiar with Arduino and how this works. But an Arduino sketch is essentially just C code, and it has two functions that run. First is the setup, where you set up all your pins that are on the Arduino that you can be using to receive and transmit lines. Tell it what other additional pins you want to be able to use for serial connections, etc. And then then it passes off to the loop command, which just runs your actual code that's going to tell your device to do something. And it runs that code as fast as it possibly can. So if you want it to run it periodically every 1 second or 2 seconds, you have to sleep the code or do something to make sure that it doesn't loop too fast. Once I started looking at this, I said, there's something really wrong here. I set out to do Ruby, and why am I looking at C code? This is not really that cool. So I started Googling for other options, and as it turns out, there is a project called RAD, and it was demoed at Ruby conference, I believe, about 5 years ago. Some of you here might be familiar with it, but RAD is Ruby Arduino development, and I was pretty excited to see this until I checked the Google mailing group, and there's this guy with this awesome name called Lennon Jesus, and he asked, is the project still, is the project development stopped? And the guy replied and said, yeah, for the most part it is, but you can check some branches to see if you can use it. Now the Ruby Arduino development, the RAD project, was pretty cool because you would write all your code in Ruby as opposed to C on the Arduino. And you'd write all your Ruby code, and then you'd run like a rake task, something that was similar to a rake task, and it would take your C code and convert it to, or take your Ruby code, convert it to C code, compile it, and put it on your Arduino for you. Now, the reason that it was not going to be a good option for me is that the Arduino Uno, which is the Arduino 1.0, it just came out when I bought my board, so it was brand new. A lot of the libraries that the Uno was using had changed, and I feared that I would be debugging a lot of compiled C code that I had not actually written, and that was going to be a pain. So I sucked it up and decided to write some C code, and I'm not going to talk about this very much, but this is just an example Roomba sketch where I do the setup method where I tell the Arduino I'm going to be talking to Roomba on a particular pin, and I'm going to be talking to him at the baud rate of 115,200, and then I tell him to write some particular commands to Roomba to set it up. And in this particular sketch, I also designed it so that maybe I could pass commands to the Arduino on a different set of pins from Ruby, and then the Arduino would pass those commands to Roomba. This was actually very, very painful for me. I did not enjoy it a whole lot, because debugging the Arduino when using it with the Roomba was not very easy. Specifically, when you connect the Arduino to the Roomba, it gets its power source from the Roomba, and it runs its code constantly. And sometimes the Roomba would light up and do something. Sometimes it wouldn't do what I thought it was supposed to do. Maybe I'd written some bad C code. And so I'd have to unplug it from the Roomba and then plug it into the USB adapter on my MacBook and try to find out what was wrong with it, and debugging was just a little painful for me. Mainly because when you're working with the Arduino, you would have to disconnect it from your MacBook after uploading the sketch and compiling it, and then connect it to the Roomba and see if Roomba does everything. It's rather headless. And another issue that I had were some documentation woes, because it had just gotten to Arduino Uno. Some of the libraries had changed, and I didn't realize what was actually happening. So a lot of the code examples out there were not up to date. So I was able to turn Roomba on, but how the hell do I get past first base? And that's a big question that I had. I really wanted to do something a lot simpler than writing C code and trying to debug it headlessly. Well, as it turns out, there's actually a lot of really easy ways to connect to Roomba. As I've already said, we connect with an Arduino microcontroller. Please excuse my horrible art. Arduino microcontroller, there's another option that you could actually add an XB wireless adapter to the Arduino, and this actually solves one of my problems of it being headless. The wireless adapter on the Arduino would allow me to connect to the Arduino from my MacBook while the Arduino is connected to Roomba and sending Roomba commands. That way I can get at least output to see what is being sent to the Roomba, so I can know what Roomba is actually getting. Another option is Bluetooth. You can get a serial port to Bluetooth wireless adapter connected to Roomba, and then just sync with your MacBook and control Roomba. Another option is straight serial, USB to serial cable. You can, there's an adapter for that. You just run cable straight to the Roomba. And perhaps the most awesome option out there, which I discovered, is a Wi-Fi adapter. You can connect a serial to Wi-Fi adapter, which will allow this is called a Wi-Fly, the particular device I'm referring to, would get its own IP address from the router automatically, and then that way you can communicate with it from any particular device. It doesn't have to be just your one MacBook that you've synced it to or connected it to. So where do you start when you've got something like this? Well, the best place to start is always with the simplest. Get rid of all the possibilities for something going wrong on a network and just go straight with the cable, and that's what I did. And that's when I finally got to writing some fucking Ruby code. Thank you. This is my initializer. It's not all that pretty, but it's for a Roomba class that I was writing in Ruby. And the initializer is pretty simple. It just takes a port or the address on your local computer where the serial port shows up. You sleep it for a 0.2 of a second to allow Roomba to boot up in case he's booting up. Then you send him a particular start and control code. As it turns out, writing anything to Roomba is most of the commands that you send to Roomba are pretty basic. All you're really sending to it are just opcodes. For instance, if you're wanting to tell him to start up or to do a particular clean session, if you want him to clean the floors, you would send only just a single integer converted to a single byte. For instance, this API setup start was just me modeling the Roomba API documentation in Ruby code. It's not all that amazing, but you're just writing a particular opcode 128, which tells Roomba to get ready to be put under control. Run 130 tells him, okay, I'm going to take control of you now. And 135, when you write that there at the bottom, it tells him, hey, I want you to clean the floors. And he would end up cleaning. Now, some of the other methods or Roomba open interface commands are a little bit more complex. For instance, the drive command, if you want to take control of Roomba and actually drive him yourself, you would have to send a 137 opcode, and then after that you would have to send 4 additional bytes. And the first 2 bytes are actually combined on the Roomba to make a 16-bit signed integer that Roomba uses to calculate the velocity for the wheels. And the last 2 bytes that you send are combined on Roomba again to make a 16-bit integer. So some of these would require different numbers of parameters. And another API command is called query list that's listed in the documentation. And it can take an unknown number of bytes, and essentially you just write opcode 149 to Roomba. You're just sending a command, opcode 149, hey, I'm going to tell you, I want you to send me a query list of some particular sensors, and the number of sensors that I want you to give me are maybe 7 sensors, so you would send 7 bytes next. And then those 7 bytes would be the particular sensor ID for each of the sensors that you want, like bump and wheel drops, or is there a cliff ahead, or do you see a wall, or anything like that. And then as soon as you write it, you would have to sit there and you would have to, well, first you'd have to wait for at least 15 milliseconds, so that way Roomba has enough time to gather all those sensors and put those on the serial out port, and then you would read from Roomba. And the bottom of the barrel, which is essentially the write command, is just taking all your bytes and converting them to single byte characters and printing them out to the Roomba. And the read command is just pretty basic. It takes your serial connection, sets a timeout to make sure that it doesn't hang forever, and then it tries to read as many bytes from Roomba as it can for all the sensors that maybe Roomba is sending data back to you for. And so finally, pulling it together, you would look in your dev and find your serial device, your Jumpin' Rails console, and you would connect to it. And I'm going to do a quick Hello World demo with Roomba. Now, usually in physical computing, Hello World in physical computing is just turning on a single LED light. But I'm going to do a hello Roomba, which is, oh, I need to get in Rails console. So I'm going to say ru equals Roomba.new. Oh, actually, I don't want to do that right yet. Roomba.new, sorry. I've already looked in my dev and found my address to my Roomba. And this should return a connection to my Roomba, or maybe it won't. This is what you get for doing live demos, right? I think Roomba was sleeping on me. Okay. Okay, so now Roomba has returned an object, and now I can tell Ru, hey Ru, I want you to, I'm just going to use the API commands which are not abstracted yet. I'm going to tell him to drive, and this is how you would tell a Roomba to drive. You'd send him 2 bytes, and for instance, I'm going to tell him, I want him to drive at a positive velocity, and I don't want him to turn at all. And now Roomba starts moving. Now, if you notice, Roomba's not stopping even if I'm pushing him or doing anything. He's just going to keep going. And that's the interesting thing about this drive command. Excuse me. The interesting thing about this drive command is that it only tells him to move, right? And this brings me to the first pitfall, forgetting to say when. If you're doing anything with Roomba and you're telling him to start moving, you have to know when to tell him to stop. And you have to just constantly ask Roomba, what do you see? Have you seen anything? Have you hit anything? And if Roomba replies with that, that's when you have to tell him to stop. He's not going to do it by himself when you're in full control mode. So how do you get information from him? Well, you ask him for status reports. And here on the left is just this gigantic hash that I mapped out, trying to map out all the different sensors that Roomba has that you can access. And this table here is from the documentation, and there's just large groups of sensors. I think there's close to 30 or 40 different sensors that you can get from Roomba. And a lot of these have different values, and like the bumps and wheel drop brings back a bunch of information on has any of the wheels, any particular wheel dropped, etc. I'm going to quickly digress into something that was a bit difficult for me, and that was dealing with signed and unsigned values coming from Roomba. A lot of the packets or sensor packets come with like data bytes that are two bytes and they're unsigned, or they may be signed. And for me, an interesting problem, or something that I never really experienced with working in Ruby at that time, was dealing with binary and signed integers. And some of you may be familiar with this much more so than me, but the way that Ruby shows or handles signed integers is that if you were to convert like -500 to the binary representation, it seems to just take the bits and then add a negative sign on the front, which was kind of interesting to me. So the reason why I had to deal with binary is because I have to pull back, say for instance, 2 bytes from Roomba, read those 2 bytes from Roomba, and then combine those 2 bytes to get a single integer value from Roomba, so that way I know what is the sensor actually telling me. I ended up having to dig into some working with 2's complement and bit shifting, and I'd never done this before. It was rather interesting and actually kind of fun, but I don't know if I want to do it much more than once. I also want to digress and say something cool about working at CookPad specifically was I had a problem with hex and with Ruby 1.8.7, and I thought it was just really strange that Ruby 1.9.3 was completely different. And I sent out an email to all my coworkers. I was like, hey guys, look at this output in console. What the heck's going on here? And I swear it was like 5 minutes later, Munata-san replied and was like, oh, that's a bug. Here's the Japanese mailing list, blah, blah, blah. And he was like telling me everything of what was going on. And I was like, wow, that's so cool that I can get a reply in like 5 minutes from my coworker. One of the guys that's a core committer. So moving on. I've already showed that we can do API drive, and that's not really all that sexy. What I wanted to do was abstract that to a move command or something like that, because I don't want to tell Roomba like all these really crazy velocity high, velocity low. I just want to tell Roomba, I want you to move, what, 3 feet. Move 3 feet and stop. That's as simple as it gets, right? And to do this, you just make a method. For instance, this is I'm defining move, and I tell it the distance. Since we already know that we have to send a velocity to Roomba, the simplest thing is to figure out if you want to tell them you want to move 3 feet. Well, in this instance, everything is in millimeters with Roomba. So you tell them you want to move 100 millimeters. You can calculate with the velocity exactly how much time that's going to take, and then your code can sit there and loop and check sensors during that time. And as soon as it's taking X number of seconds to reach that distance, you can tell Roomba to stop moving. So this is the move command. At the very end, he sends another drive command that tells him to stop and checks the sensors again. So I'm going to, on this particular demo, the Roomba will actually move, and he should respond if he gets hit. If he touches anything, since I'm checking the sensors, he should respond and stop moving. I'm going to tell him to move 1,000 millimeters. Oh, this is the other interesting thing, is that Roomba, if you pick him up at any time when he's moving, if you pick him up off the floor or anything, he instantly goes out of control mode and goes into passive mode. So what happened just now is I sent the command and told him to move, and then there's all this sensor data that popped up on the monitor there. And all the sensor data was coming back, and it was saying that there was nothing. It was a formatted 0 in this basic sensor data. It's just saying that it has not seen anything. And that's the truth, because Roomba had not moved anywhere. But you can still get sensors from him. So what I want to do is, I have to call setup start. Tell him that I want to take control again. And now this time, if I tell him to move, he should actually move. Oh, and again, Murphy strikes. Okay, let's try this again. Okay, it's kind of hard to see, but on the monitor there, Roomba, the light is green on his clean button. It's a little button in the middle. And now that I took control, his light went off, which means I'm in control. Okay, so what you witnessed was Roomba moving. I didn't get him to stop until I hit him a couple times. And this is actually part of the demo. That was not a mess up. And that's the pitfall, the next pitfall that you're going to run into with doing some physical computing, or most anything type of physical computing, is latency. There's an issue with working with Roomba and physical computing, is that if you ask him, for instance, instead of "are we there yet," is "have you seen anything yet? Have you hit anything yet?" You might ask him, and then over any type of wireless connection, or because of the amount of time that Roomba has to take to read a sensor and then send it back to you, you might end up missing some data, or maybe you ask him the first time, he hasn't responded, so you just got nil back. You check again, and then that time he responds. And for instance, I hit him 3 or 4 times, but it was the last time where I kind of held the front bumper is when I actually got a response that was positive that he had hit something. So regardless of the fact that there's a latency issue, I want to just move on and do something even, I just want to cut out all the middleman, and I want to be able to control Roomba even from a server way out in the cloud. And so now I'm going to move on and say, let's get rid of the Arduino, which we've already done with the C code, and let's get rid of the Bluetooth adapter and just control the Roomba wirelessly from some Rails app. And this is how you're going to do it. This is the device called the Wi-Fi. This is after I've soldered some pins onto it. And the Wi-Fi made me have to learn a little bit about wiring and wiring diagrams and something called logic level converters. For instance, the Roomba speaks on, all his serial ports run on 5 volts, that's his signals. And while the Wi-Fi itself runs on 3.3 volts, which essentially means that if you were to just connect those directly, the Wi-Fi, because it's very sensitive to differences in voltages, would probably just fry and you wouldn't actually get it to do anything for you. These two particular circuit boards, on the left right here is a power converter, which allowed me to convert Roomba's power so that way the Wi-Fi could be powered directly by Roomba. And the one on the right is the logic level converter, where I was able to, it steps down the Roomba voltage levels. I had never done anything with this, anything like this before, and I've never done any type of breadboarding. I actually found that this was really, really fun to breadboard, although it doesn't really do much other than just prototype and tell you what it should probably look like. So how do we actually control Roomba from a Rails app or a web app? And up until now, we've been using this serial port gem to control it. But actually, since you're going to be connecting through Wi-Fi over a wireless network, you probably want to do it with an IP address and a port. And you can do that strictly through using TCP socket, which is default with any Ruby install, right? And so I did everything. I'd done all the soldering. I set it up, connected it. And then I connected to my Wi-Fi with TCP socket, and I was able to send Roomba a couple commands. He moved, but I never got anything back from him. He wasn't speaking to me. I couldn't get any data. Apparently, the Wi-Fi adapter which I have, which I'm not demoing here because I'm afraid wireless network might be a problem for a demo, but this particular Wi-Fi is pretty cool because it can create its own ad hoc network. As soon as you connect it to the Roomba, it will create its own network. You can connect to the Wi-Fi and don't have to use a router. But the problem with the ad hoc network, I had a problem trying to get any data back. And I probably pulled my hair out for like 2 days trying to figure this out. And eventually I was Googling, trying to find anyone that had this problem. And I think there's only one other guy in the world that had this problem or even blogged about it or said anything. And it was on an Egyptian hackerspace blog. And I found this guy that said, hey, I'm able to send stuff to my Wi-Fi, but I can't get shit back from it. What the hell's going on? And some dude replied like 2 days later and didn't even answer the question, which is cool and all. But what really was awesome, this guy came back, even though he had already just solved the problem, and he said, hey, don't worry, I solved it. What it was is that in ad hoc mode, even though in the documentation you can't receive anything. And I was like, oh God, you're an angel. Thank you for writing this. So directly after that, I dropped the ad hoc after I'd done the configuration settings for the Wi-Fi, connected it to my router, and boom, I was able to send and receive over the wireless network. But the crazy thing is I started just getting a whole bunch of shit from Roomba. Like he was just sending me all this crap and I couldn't read it. Like it was not normal sensor data. And this is another pitfall. And what you do when you're in this situation, there's actually 3 solutions. And the first is read the fucking manual. This particular Wi-Fi device, I went back to the manual and I started reading all the options. It's like, what the hell did I do wrong? Why is he sending me a whole bunch of crap? Maybe it's not from Roomba. And if that doesn't work, reset your Roomba to factory defaults. And the way you do this is pull out the battery, hold the power button down for a few minutes, and then put the battery back in. He beeps up all lively and says, oh, who are you? And then you have to strap another knife on him so that way he'll remember you later. And if that doesn't work, which in my case it still did not work, go back and read the fucking manual again. That's the 3rd solution. And actually, even better yet is ask your coworker, thank you, Miles, for reading the manual with you. And then you end up finding this really obscure thing that you just assumed didn't really matter to you. And for instance, in this thing, the Wi-Fi, by default, like if you connect to it over a wireless network or over an ad hoc network, it doesn't send you any debug information. But by default, this Wi-Fi was sending debugging information to the serial outs. So what he was doing was sending, like, he was printing out everything. The Wi-Fi, as soon as it booted up, would print out every bit of debugging information to the Roomba. And Roomba was receiving all this data and just thought it was a bunch of commands. And some of it would interpret, and some of it would not interpret. And so apparently Roomba just got like flooded with thousands of commands like really quickly and was just sending me a bunch of bullshit back that I could never figure out. So the magic configuration with the Wi-Fi adapter is set your COM closed to 0, set your COM open to 0, and set your sys print level to 0. Now these 3 things say whenever you make a connection to the Wi-Fi, don't print anything on the COM port, don't print anything on the serial port. When you close your connection to the Roomba, don't do anything. And when you start up, don't write any fucking debug messages, and that's it. So after 2 days of tearing my hair out, that pretty prototype I started with ended up looking like this box of wires and cabling. That's a sad sight, but that's what it was. So this is a quick video. Yes, it's funny, isn't it? And this is me controlling my Roomba wirelessly over the network. Sorry it's such a bad video, but it's kind of hard to see. I've just called Roomba new and I sent an IP address. It was the 192 local IP address. The light on the Roomba went off, which means he's under my control. And then I send him a move command. And I just hit it, and there's a little bit of latency, about a second and a half, and then Roomba is spinning happily in place with a box of wires. Not too cool, but it was fun. So that's my Roomba and the Wi-Fi. So now that I've talked about Wi-Fi and wirelessly connecting, I want to talk about 3 final hurdles. And the 3 final hurdles have nothing to do with dogs on Roombas, nothing to do with cats on Roombas, and nothing to do with bears playing keyboards. Actually, the 3 final hurdles have to do with Wi-Fi and using Rails apps. And I'm going to get to the Rails demonstration in just a moment. But now that we've got all the base code, how do you actually talk to the Roomba using Rails? And what you would normally do is if a request, like you make a request through your web browser to some Rails app code, and it would open up a TCP socket to your Roomba. It would pass a command to the Roomba through the Wi-Fi. The Wi-Fi would send the command to Roomba. Roomba would reply with, like, for instance, if you told them to give me move and to give me sensor data and keep giving me sensor data, what you'd have to do is hold that socket open and just keep reading. Now the problem with that is you're holding and you're holding and you're holding, and your request doesn't finish, so the browser wouldn't actually be able to display what's happened until after all that request has happened. So what happens if I tell Roomba to move 2 miles? I'm going to be holding for a very long time while Roomba is moving for 2 miles. Now it works fine if you're just telling Roomba to move like 100 millimeters, because that's less than a second, so the request finishes pretty quick. Well, now this is the cool thing about the Wi-Fi, the actual piece of device, the Wi-Fi, is it has another option that you can configure it with, where, for instance, if you take a Rails app and you make a request over TCP socket to the Roomba and you tell Roomba, I want you to move and I want you to update me with sensors every 15 milliseconds, the Wi-Fi has this cool option where it can, if you configure it, take any data that it receives over the serial port and automatically forward that in some restful manner to any web server on the planet. So you could just say, here's the URL that I want you to post or to send any of this data you get. So it would just post all those bytes that it got back. And it could do that every 15 milliseconds, perhaps. So that's a cool way to get over that hurdle. Another hurdle that you have is the stateless web tags, where every time you're making a new request to Roomba, you have to initialize a new Roomba object, and Roomba has to sleep. You have to wait 0.2 of a second plus another 1/10 of a second to start the Roomba, because the Roomba has to be able to have time to boot up before you start sending the commands. That's another hurdle. And the third hurdle, which is very similar, is the device busy. If you have 2 concurrent requests that happen at the same time from a Rails app, and the first one gets through and he has the port open to the Roomba can only service 1 master at a time. The other request is just going to get an error busy, and you won't be able to get anything. So that's kind of broken. I tried to hack up some way to fix these problems, and I came up with this really weird idea that maybe I could have like a socket server that runs. Maybe the first Rails request that comes in would start this socket server, and this is some pseudocode on the right, and the socket server would create an instance of the Roomba class and hold that instance open for all future requests until maybe it timed out at some particular point. And that way, every request that comes in immediately afterwards would not have any boot up time, wouldn't have to wait at all for Roomba to sleep or get any commands to get set up. So you could just pass them anything. And also this socket server could be like a queue. So if you send them a whole bunch of commands really fast, it would queue up and it wouldn't cause Roomba to go crazy. So now I'm actually going to do an extended demo with the Rails app, which is probably the one thing that you guys were wondering, where is Rails in this? And let's see if I can get this. Okay, so I've got a Rails app that I've written. Quick, move. Let me try to get photo booth on here too. Okay, I don't know how I'm going to do this very well, but here's video. Here's the Rails app. It's kind of hard to see, but I've just created, so if you were to go in here, and this is Roomba Blue because I'm running on the Bluetooth adapter. You could edit Roomba Blue, and essentially all it's doing is the location. Where is Roomba Blue? And this is a serial port. In normal cases, if you're using Wi-Fi, you would actually have an IP address with a port on the IP. Roomba Blue here, when you come in, you can either take control of Roomba Blue or you could exterminate him if he's a Dalek. Doctor Who fans? I heard some people laugh. Okay. So this is a Roomba, and I'm just going to take control, and if we're lucky, in about 3 seconds, a report command goes, and boom. Now this is some information I'm pulling from Roomba's sensors. It's telling me right now, sorry guys, this is hard to see. It's telling me right now that Roomba is in safe mode. His battery charge is 2,500 milliamp hours out of his total on his battery. The current amount of milliamps that are running out of Roomba is negative 211. You can get a temperature of his battery. You can find out if he's docked or undocked, is he charging, etc. And I've just got this running on Ajax. It's kind of periodically pulling Roomba and saying, hey, give me a report on your sensors. And now what we can do, if I get this camera for you guys to see, I can tell Roomba, hey, I want you to move 100, maybe I want you to move 500 millimeters, which is not really that far. And I just want you to move at the default velocity of 200. And so Roomba moves. And it sends back all the sensor data here. These are bumps and drops and telling you if you've hit anything. We could also tell him, hey, I want you to move a little faster. I want you to move backwards at a negative velocity, 500. And I want you to move at, I want you to move back 1,000 millimeters. So, okay, Roomba, let's go backwards. And Roomba goes a little faster. And as an additional, probably the most practical thing, now this is a way that you could control Roomba manually if you wanted to tell him to move. Probably one of the more practical things that you would want to do with a Roomba remotely over the web would be to set up a schedule, because scheduling him by pushing the buttons down there is a pain in the ass. You have to actually bend over and start pushing buttons. What the hell is that? For instance, you could just send him hours and minutes of whatever day of the week that you'd want to set the schedule. So for instance, you'd tell him that on Mondays, I want you to clean at 10:30, and he would say, yes, my lord. And that would be schedule updated. So now if I go down there and if I push the button to turn him on to check his schedule and actually do the manual thing, it would show up as 10:30. It's already updated now. You could also clear the schedule. So this would be really cool if you're out on vacation and you're like, oh, I'm going to be home tomorrow. Let's clean the house. Roomba, go clean the house right now. And you can log in with your iPhone. There's some other things like the motors. You can control all the motors. I'm not going to go through this demo because I think I'm running out of time. Another thing that you can do, I don't know if you guys can hear this, but Roomba has a MIDI, like he can play MIDI notes. So you can queue up songs and then tell him to play these songs. For instance, I'm just going to tell him, here's all the notes. Now these like map out to like particular notes on a keyboard or whatever. And so maybe some of you heard that. Maybe not a whole lot of people. And now I'm just going to go into like a full demo. And if everyone's quiet, there might be a surprise in this demo. Roomba's going to try to sing us a really cool song while he's running around. This full demo, which all the sensors up here would be updated, hopefully, will run through a whole bunch of commands, and I'll try to tell you what's happening while it's going on. So Roomba is just turning around. I'm proving that we can control him to tell him to move in any particular direction. And I'm telling him to back up and just turn on any particular motors. Now I tell him to turn off the motor, I tell him to just spin, and I'm going to tell him to reverse and go a little bit faster when he's spinning. So these are just basic move commands. Tell him to sing again. I can tell him to go into a regular cleaning mode, which now, and then I tell him to turn off. And I put him into 2 different cleaning modes, and then I turn him off because I was afraid that he might go a little bit too far away from the stage. But that was me controlling Roomba from the Rails app. Thank you. So looking forward, I want to, oh, cool, I got a couple minutes left. Looking forward, I just want to talk about where I'm at now and what I wanted to do. And one of the things when doing with physical computing devices is, how the hell do you test them? How do you write tests to test something that's in the real world as opposed to just software that you can easily test? And I had an interesting story told to me that a guy was talking to a guy from Northrop Grumman, and particularly asked this question, like, how do you test those drones that fly around and stuff? And the guy said, what do you mean? And he's like, well, how do you write like software tests for these? And he said, well, you write a simulation and then you test the simulation. And I was like, okay, you test the simulation, that's great. And then how do you know that that matches the real thing? And he's like, well, you really don't. You just have to keep testing the simulation and then comparing it to the real thing to see if it's the same. And so my idea was a couple months ago was, hey, it would be really cool for all those people that don't have Roombas if I could write like a software simulator, a software simulation of Roomba. And that way we could write a lot of really cool scenarios and test those scenarios against the software. And then I could run that same scenario on the Roomba and see if given the same arbitrary boundaries of some particular distance and some obstacles in there, would he return the same sensors at the same time as the simulation did? And so I set out and tried to make a quick simulator. I wrote a simulator and then we ran tests and scenarios against the simulator, and then we ran some of those simulations with the real thing. Now this simulator, it's in the project, but it's not up to par. It still has a lot of work to be done. But if you're just moving forward and backward and some really basic moves, it's pretty close. So that's pretty cool. But doing a lot of the making Roomba move at angles and stuff, that's hasn't been very easy to make. So it'd be really cool if you could just write a whole bunch of scenarios, anyone in the world, and say, hey, what would happen if this physical device done this? And then boom, Roomba, of course, would say, bring it. I'm ready. And then you could maybe queue up all these simulators and then control Roomba over the web. That would be pretty cool. For instance, what if I taped a marker on the side of Roomba? Here would be a pretty cool challenge. Could any of you draw something on the floor if I taped a marker on Roomba? Could you like simulate him moving around to draw like your name on a piece of paper if you had a marker on them? And then if you were to run that in a simulation and run it in real life, how close would the real life drawing be to the simulation? Or could you map out the room? Or something more complex? And so physical computing, so why the hell should you care? Why should you care about Roomba and Rails, etc.? And it's not just because Techno-Viking tells you need to care, but I'm going to give you at least 50 billion and one maybe reasons. By 2020, there are going to be 50 billion connected devices. This is from an Ericsson white paper. And TechCrunch had a recent published article that talked about 2012 that the number of mobile or wireless devices already exceeded the population. Out of those mobile devices, by 2016, there's going to be 16 billion mobile devices, and a large percentage of those are going to be machine-to-machine only. So there's going to be room for software that only controls machines. It's not just particularly for your mobile device like your iPhone. So maybe people will want to automatic or control Roomba over the web. For instance, everything that was consumer electronics is going to be moved into just about everything is going to be networked. It's going to be ubiquitous computing, right? Some people are doing some pretty cool things with Wi-Fi. I'd like to talk about those, but I think I'm running out of time. This one, for instance, was just a quick proof of concept that a guy made a clock with a Wi-Fi, and on this clock he gets updates from Twitter and the weather report and all sorts of things that the Wi-Fi is being able to pull from servers and display. This guy done a really cool project in New Zealand where he used an Arduino and some water sensors, and he was able to put water sensors in tanks around his giant farm, and wirelessly over the web he was able to pull those and find out how much water was in his tank. That seemed like a pretty practical thing to do. If you're not looking for all that practical or just looking to really get into robotics but you don't really want a Roomba, you could get something like a Create, which iRobot sells as the machine without all the vacuuming parts. They're pretty cheap, easy to get. And maybe you can make this bionic hamster version that they got here, where a hamster's running around on the wall on a wheel and the sensor underneath it picks up and knows to tell Roomba to go that direction. That seemed pretty cool. So I want to finish, my last reason why you should care about hacking Roombas is more to do with what I talked about in the beginning, that the greatest obstacle to discovery is not ignorance but the illusion of knowledge. And in this sense, if you're ignorant of physical computing, I think you should adopt the pragmatic philosophy and just go out and try it. See what it's like. Invest in your knowledge portfolio. And in fact, I think you should be like a guy named Simone Steven. And if any of you guys have ever heard of Simone Steven, he's a historical figure, and he was an eccentric. This guy was, in the 1500s, he was pretty crazy because he was one of the only people that had amphibious vehicles. He drove this thing around. It was called a land yacht. I would be sure to think that he was kind of weird if I saw him in this. But Simone Steven was pretty interesting because he worked on so many different things throughout his life. And most of the things had nothing to do with his forte, which was just engineering of bridges and dams and stuff. But in 1585, he published this book called The Tenths, which was, hey, I think we should use the decimal system for all your measurements and stuff. At that time, most people were just using fractions, like 1/3. They would write 1/3 as opposed to like 0.33, etc. And this small thing that he did actually ended up, he just published it. It was one of the small things. He didn't think it was all that important. He'd never really dealt with publishing about measurements. It ends up changing the world where everyone uses the decimal system. And what he ends up saying is what seems a wonder is not really a wonder. And if you are ever like thinking that some of these physical computing projects are just too difficult to get into, take it from me. If it seems like a wonder, it's not really a wonder. It can be done. So if you have a chance, fork it, and thanks for coming.